Hello, this is my lab report for Lab 2, Lines of Charge. The purpose of this lab is to analyze the difference between a point charge model and a distribution of charge model. To do this, we will be using a glow script model, which has lines of point charges. The main principle we will use is static equilibrium, which will calculate that between our gravitational and electric forces. And our brief preview is that our new charge of the tape is 9.54 times 10 to the negative 9 coulombs. Key principles. So gravity is negative mg in the y direction, and our electric force is the charge of our observation point multiplied by E net at that given point. And E, the formula for electric field, is given on screen. Now forces, they follow the superposition principle, which means we can just add them all up to get our net force. And what we're looking for is something like the bottom here, where Fe and Fg cancel out to give us an F net of 0. Reasoning and assumptions. For simplicity, we'll say that the charges are the same and that they're evenly distributed throughout the tape. And now for our glow script model, we'll say that each tape can be modeled as a line of 100 point charges, and we will only be accounting for interactions between the tapes and the earths. System versus surroundings. Our system is the top piece of tape, and our surroundings are the bottom tape and the earths. Initial conditions. For this lab, we're not really concerned about how stuff changes over time, but we can say that an initial condition could be when the pieces of tape are held so far apart that they do not exert a significant force on each other. Experiment process. So we'll create two charged pieces of tape by quickly ripping them off a smooth surface. And we'll place one tape such that it is horizontal with a slight sag, and then we'll take our second piece of tape and hold it underneath that top piece until the top piece has hovered and it stops moving. Here's some photos of the experiment and our results from a previous lab. In the lab where we assumed the point charge, we found there was a charge of 2.53 times 10 to the negative 9 coulombs. Our computational model for this lab begins similarly. We'll set all of our constants and experimental values on the left. We will also create lines of point charges. In this case, we'll have 100 point charges per line. Now on the right, we have our for loops. So we will see how every point charge from the bottom line will interact with every point charge in the top line. So we will find each electric field and sum them together, and find each force and sum them together. So that'll get us all of our net fields and net forces. And then the bottom we have visualization. Here's our results. The green arrows represent the net electric field at each specific point charge. The white is the net electric force acting on that entire line of red point charges. And the yellow is the net gravitational force of the entire line of point charges. Similarities and differences. In both this model and our previous lab, we found that we had static equilibrium where F net equals 0, and we saw that F net electric was in the positive y direction. However, in this new model, we have a bit more information because we can see that there are also forces in the x direction that cancel each other out. Sources of error. There might be some issues with our assumptions because the charge of the two tapes may not be equal and they may not be uniformly distributed. There also could be some issues from not handling the tape properly or from imprecise measurements. What if and why? So we found that our estimated charges was very different. For the point charge model, it was 2.53 times 10 to the negative 9 coulombs. But for our line model, it was much greater at 9.54 times 10 to the negative 9 coulombs. So now why are these different? Well, there's a big difference in complexity and precision. For our line model, we take into account the fact that these two pieces of tape are not only interacting in the y direction, there's also some stuff happening in the x direction. They just cancel out. And for that reason, this higher level of precision makes this line model more accurate. In conclusion, we found that each tape had a charge of 9.54 times 10 to the negative 9 coulombs, and that all the net forces act in the y-axis. However, if we break apart our line of tape into smaller point charges, we'll find that there's forces in the x-axis, but they just cancel each other out.